This video is about insulators and conductors. Let's start with a couple definitions. A conductor is a material that allows charges to easily flow across it. And an insulator is a material that doesn't allow charges to easily flow across it. It's not really a black and white issue. Some materials are very good conductors, and so they're poor insulators, or they're very good insulators, so they are poor conductors. But many materials are somewhere in between. They're either exactly in the middle, or they're decent conductors, but they're not real good conductors, or they are decent insulators, but not real good insulators, or anywhere in between. Examples of good conductors, or in other words, poor insulators, are metals, such as a piece of copper, where the electrons can flow easily across the copper. And a salt solution is another good conductor. So in the solution, the salt breaks up into positive sodium ions and negative chloride ions. And these ions are free to move around the fluid easily, so it's a good conductor. Examples of good insulators, or in other words, poor conductors, are rubber, plastic, wood, glass, PVC, and plexiglass. There are, of course, many more examples of good conductors and good insulators that we may get into as the course progresses. So this property determines how well or how poorly charge can be transferred between objects. For instance, say I have a negatively charged plastic ball, and it comes in contact with a neutral metal ball. So at this point of contact, no significant charge is transferred. Because the plastic ball is an insulator and the charges can't flow across that plastic ball to get to the metal ball. And so after the objects are separated, you basically wind up with what you started with, a negatively charged plastic ball and a neutral metal ball. But now let's consider what happens if both objects are metal, are conductors. Where this one starts off negatively charged, and this one is initially neutral, but now the electrons are free to flow around the charged metal ball, and so they can flow through the point of contact onto the other metal ball. With the result that after they're separated, they're both negatively charged. Now don't forget about charge conservation. Notice that the net charge we started with has to equal the net charge that we ended with. So we may not know exactly how the charge is split between the two metal balls, but we know that they must add up to the same amount of charge that we started with on the one metal ball. So that initial Q is the same as the combined Q's on these two objects, say Q1 and Q2. Okay, so that's the end of the video on insulators and conductors.